dark energy was discovered, and a Nobel Prize was given for it. And this has made people take this idea quite a bit more seriously. It's still fair to say that it's very controversial. We don't know, but it's certainly a scientific question we can discuss, whether our reality is this big. We should also be mindful that we humans have again and again made this mistake of underestimating the size of our cosmos. First we thought Earth was the center of everything, right? Then we discovered that our solar system existed in a galaxy and a universe. So it might very well happen again. There's no guarantee in the laws of physics that we humans should be able to see everything that exists. And if we cannot, by definition, there are parallel universes. Well, and there's even more. There's a third kind of parallel universes which have come into the scientific discussion from studying not the biggest things, but from studying the smallest things, by studying quantum mechanics, the rules that govern how atoms and elementary particles behave. This is arguably the most successful theory in all of science. It's given us transistors, computers, cell phones, lasers, etc. But at the cost of some weird ideas. Quantum mechanics tells us that little particles can be in several places at once. If the particles can be in several places at once, well, I'm made of these particles. I should be able to be in several places at once as well. And in 1957, a young graduate student named Hugh Everett worked this out really carefully and argued that what it really means is that there is a third kind of parallel universes, where when you make certain decisions, effectively our world splits into several parallel tracks. If I get a parking ticket, there is a parallel universe maybe where I didn't. But there's another parallel universe maybe where my car was stolen instead. So you win some, you lose some. This sounds very philosophical, but it's the way to test this, again, is not by speculating, but by studying quantum mechanics more. In particular, we should try to build quantum computers, which is a kind of machine which takes advantage of parallel computation and effectively using these parallel worlds. If we try to build them, and there are millions and millions of dollars spent right now to try to do so, if it fails, because we notice that the basic equation of quantum mechanics is wrong, then we can forget about all these parallel universes. But if they succeed, and they can calculate something in 5 minutes that would take longer than the age of our universe to do on a normal computer, I think that will make many scientists take these parallel universes more seriously.
A quantum computer is a device, a technological device that in principle would harness the full capacity of quantum mechanics to undertake calculations that a standard computer would be absolutely unable to achieve. One way of thinking about it is this. There's an approach to quantum mechanics where one imagines that there are many, in some sense, parallel realities moving along in some larger environment, if you will, where, for instance, if I want to measure an electron, quantum theory says, well, there's a 50% chance it's there and a 50% chance it's over there. And now what does that mean? Well, one interpretation says, well, there's actually two universes, and in one universe the electron is here, and in another universe it is over there. That's kind of a crazy sounding idea, but a quantum computer perhaps can harness that by doing some calculations over here and other calculations over there in parallel. Now it's doing, in some sense, twice as many calculations as a classical computer existing in one world would be able to do. Now imagine taking that idea and spreading it over all of the possible realities allowed by quantum mechanics. Now you're harnessing all of these different worlds, if you will, to do all of these calculations in parallel. Much faster, much more powerful, doing calculations that in a single universe would be impossible. So this is one way of thinking about it, and it offers amazing possibilities, and we just need to see how successful we are at harnessing these ideas to actually put it into practice. And that we don't know yet. We'll see going forward, but it's an exciting possibility.
The best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?